Hello, everybody, and welcome back to the Data for AI Week Conference 2020. This is the last live day of the conference, Friday, September 18th, if you forget what day of the week it is, which is easy to do in these work-from-home days. This is the 11:15 a.m. Eastern panel on predictive analytics and data in government. It's going to be a pretty awesome one. We have a great panel here. I'm really excited to hear the feedback and interaction. So, of course, 11:15 Eastern, 8:15 on the Pacific Coast. Now, if you're here in Australia, I know it's really late. In Asia, it's really late. Europe, I think now it's dinner time. So we really are thankful for you joining us live. And for those of you that are joining us in the replay, watch whenever you can. So real quick, I'm going to just put all of our panelists in the corner here at the moment. I know nobody puts panelists in the corner, but I will. And I'll bring them back when it's time to bring them back. I'm just going to do the quick orientation on the platform for those of you who are new, because I can actually see a whole bunch of people, and some people maybe who are new to the platform just joined us for today. So this conference is for you. This is all about data, the data side of AI. We have 5 awesome days of live content, but a lot of recorded and on-demand content. And this is for you. So, we're all here. We can speak to each other all the time. And actually, honestly, we do. We actually like to talk to each other all the time. But the reason why we're broadcasting is because you are here in the audience. So please do interact with us. Give us your questions. Give us your feedback. Give us your comments. Even let us know, is something not working? Is something working? Just basically interact, because we are here for you. I'm Ron Schmelzer. I'm a managing partner and principal analyst at Cognilytica. We are a research advisory and education firm focused on AI and machine learning, and we produce this conference. So if you're interested in reaching out to us, if you're having any problems with this conference or anything in general, please email us, info@Cognilytica, COGNILYTICA.com. You can see that right back there in the banner behind me. And we're thrilled to have you here. We're also really proud and happy to have the support of our sponsors and partners, who literally this event would not be able to happen without them. So we really want to thank our friends at Allegiant and Appen, Amazon Web Services, Carahsoft, Cloud Factory, Databricks, DataRobot, our friends at Labelbox, Microsoft, MTX Group, OmniSci, and Veritone. Not only are they here participating in these live sessions and providing their support, but there's lots of recorded content. There's lots of on-demand content, which you can access. Over 120 sessions are available on demand in our on-demand library. Just go to Data AI Conf and go to sessions, and you can watch sessions on data preparation, data engineering, data labeling, data annotation, data wrangling, sourcing sourcing data, generating data. There's so many things on demos. There's so many great things that you could see there that are on replay. So you can are recorded already, so you can watch them. Some of them are educational. Some of them are kind of long. There's actually some 3-hour sessions in there too. So they're not all 1 hour like our live sessions. So check them out. Some of them are really short too. Some are like 15, 20 minutes. So check all that great content out. As I mentioned earlier, this session is for you. It's all about interaction. So please post your questions down below. If you look below the video, you see the Ask a Question function. Please ask the question when you think of it. And when people see the answers, see the questions, they can upvote them, because maybe they have the same question. So we're going to keep an eye on those questions. At about the 40 minutes into this thing, we're going to start pulling in the audience questions. So put them in. Other people can comment on them and ask questions as well. Then what else do I got for you? Oh, yes. The session will be available on replay, and the replay will be available about 5 minutes after the session's over. It's a really quick replay system. So if you have to leave, we'd rather you be here live with us. But if you have to leave and you have a question, put your question in, and then if you have to leave, and then come back. And when we answer your question, it'll be available on the replay. And the cool thing about the replay feature is that when we're answering questions, I'm going to hit the little tag that says we're answering that question, and it'll timestamp it in the video, so you can come back and watch the replay and be automatically fast forwarded to that question, which is nice. A good way to coming back to where you left off, if you will. So on other notes, these sessions are always held under so-called Chatham House rule, which means that you are welcome to contribute and be part of the conversation and share and learn and use anything you learn. Just don't quote anybody in any public periodical or anything like that without people's prior consent. So people can feel happy to share. Maybe someone just thinking they don't want to comment because something might appear. Don't worry about it. This is all we're all in the house. We're all in the Chatham House. So whatever stays here, and we won't be sharing externally. Finally, also, this session is recorded. If you have any problems at all, go to the Data AI Conf site. We have an FAQ, and you can hopefully get your questions answered. And that is all I have on the little overview here. So I'm going to introduce Tony, and then he will introduce the panel and get the panel going as well. So I am really excited to have here as our moderator for this panel, introducer, Tony Sanchez, who's Technical Director, Government at Veritone. He's got an amazing background. So while serving 13 years in the U.S. Air Force and Air Force Reserves as an intelligence analyst, Tony began his career as a software engineer for BAE Systems, developing image processing and analysis software used throughout the DoD and intelligence community. After leading several system engineering efforts on programs such as DCGS-N and Worldview 2, he transitioned into IRAD, business and product development roles, where he cultivated a desire for identifying new cutting-edge solutions to solve complex imagery and geospatial analysis problems. Tony's interest in data steered his career towards entrepreneurial ventures in semantic natural language processing and all-source multi-INT information extraction and correlation, where he could apply his passion for creating new ways to automate analyst workflows to enhance decision-making. As a consultant, Tony continues to provide data science pipeline expertise in the extract, transform, load, ETL, machine learning, and data cleansing processes. Tony currently serves as Technical Director of Government at Veritone, where he's able to expand his vision by applying orchestrated AI solutions to help solve big data problems in government. So, Tony, thrilled to have you here, and bring you on board.
Well, thank you so much, Ron. Thanks for that lengthy introduction, and I really appreciate it. Thanks again for inviting me to moderate this panel. I'm really excited about this area, this topic of interest, because it's really fascinating where we're going with artificial intelligence and machine learning. Again, I'm Tony Sanchez. I'm Federal Technical Director of Veritone. I am a 13-year veteran of the Air Force, previous Intel analyst in my past life. A little bit about Veritone before we jump right in, because I do believe it's relevant. Veritone provides our flagship platform called aiWARE. We leverage hundreds of commercial, proprietary, and personal machine learning models to extract high-fidelity content from all sources of data to drive legacy and new bespoke analytic platforms. So whether it's law enforcement, advertising, surveillance, intelligence gathering, we all know you need high-quality, high-fidelity data to drive results and to better enable decision-making. So like Ron said, some of my background has really been focused on the setup, the ETL, the cleaning, the data pipelines, and really, getting data in a format where it's digestible, where it's readable, and quality data to inform decision making and processing. So, in my previous life as an Intel analyst, I can commiserate with the analyst's objective to find that needle in a haystack, and the labor intensity of that and the time consuming of it. So that's where AI and machine learning really come in handy. But when it comes to things like predictive analytics, that's an area it's really fascinating, because the term predictive analytics, much like AI, is a very broad term. It means many different things. It can mean many different things to different people, such as in data science, you are doing predictions within your models, whether if you're developing a deep learning model and you're looking at objects, you have lots of layers and you're propagating through and you're determining what is this image? Is it a dog? Is it a cat? Or what it hears? And so that form of predictions happens all the time in data science. But my true understanding of predictive analytics is sort of that next level. How are we using those predictions? How can we use them to detect patterns, probabilities? When and where something, when and where it will happen. And really, how organizations can take advantage of that. How do they prepare? How do they apply resources and so forth? So what I'd like to do with the panel, we got a great panel here. I'd like to start the conversation and have each of our panel guests introduce themselves, their role, and kind of frame a little bit what their understanding of predictive analytics is and how they see it benefiting organizations as a whole. We can kind of get to the how, but I'd like to kind of get the perspective from each of the panelists to sort of give our audience a frame of reference. And so what I'll do is let's start with How about you, Shakib? I'll let you kick it off.
Sure. Good morning, everyone. Well, my name is Shakib Shribi. I'm Chief Data Scientist and Acting Associate Director for the Office of Data Service at NTIS. NTIS is the National Technical Information Service, which is a federal agency within the U.S. Department of Commerce, with the mission of providing innovative data science and artificial services to federal agencies to advance their federal data priorities. And NTIS is all about innovation, and I hope I have a chance to talk about the framework, which is a very innovative framework. As far as myself is concerned, I came to NTIS from the academic world. I was a professor, a program chair, a dean, and then I did a lot of teaching and research at the university. And then it was all about innovation, as my background is in computer science, data science, and artificial intelligence and applied mathematics. So that experience with innovation that I experienced in teaching and doing research, I'm trying to bring it to NTIS and the government sector. So you mentioned predictive analytics. So let me give you my definition of predictive analytics. I think it's the practice of aggregating and analyzing data in order to predict future outcomes and derive insight from data. And this is essential in advancing federal data priorities, solving national problems, as well as just improving the operation for each federal agency. Central to the federal agencies is the federal data strategy that has been developed, and this year we are actually implementing the 2020 action plan that prepare federal agencies to actually leverage the data as a strategic asset in order to advance their mission and solve their data-related problems. Just to give you some problems that NTIS have been working with several federal agencies, because we have this innovation framework that allows us to partner up with the best and brightest in the private sector and in research and with universities and so on and so forth to tackle those data-related problems for federal agencies. And so we're working in so many different areas that related to predictive analytics, including fighting fraud, waste, and abuse. So we're working, for instance, with the VA OIG, with AHS OIG, making sure that every dollar spent is properly spent in a legitimate transaction. And like you mentioned, predictive analytics can be used to detect unusual patterns that will indicate some types of fraud. And the key there is to free up resources, because people are always going to be involved, but the predictive analytics can help us basically sniff across all those data that is out there. And like you said, once it's cleaned and prepared for analysis, that can help us surface those issues that can happen with fraud and waste and abuse. And we have very specific cases where we actually identified fraud, etc., and save a lot of money. So, for instance, in Medicare is a $600 billion business. So even if you have only 5% of fraud activities, that's about $30 billion. But we have to look at fraud also in a holistic fashion, because it's not about financial loss. It's like that money that can be used for some services is taken off, or maybe it creates some barriers. So we will maybe have a chance to talk about ethics in AI, and that I think it's important also to see that AI can help us implement some good solutions that will prevent unfairness in applying them, etc. So other application that we are working with is with USAID. USAID, we are helping them implement the President Malaria Initiative, so which is saving lives, literally. There was in 2018, about more than 400,000 people died across the world from malaria, and mostly children. So what we're doing with them is first establishing a good data platform that will allow them to actually collect data from literally across the world in different format, in different languages, and all type of data, geospatial data, atmospheric data, weather data, and so on and so forth, and bring it so they can make better decisions and even eventually predicting a future outbreak of malaria. And you mentioned also another aspect that we are thinking about is to use predictive analytics and deep learning algorithms to detect malaria. So in a low-cost way that can be implemented in the countries where actually malaria occurs, and usually sometimes they have low resources to do that, and it's expensive and complicated. So we're trying to use artificial intelligence to actually lower the cost and make it more practical, and then try to get that data as soon as possible so we can address malaria outbreaks and even predict them and prevent them and mitigate them. Thank you.
That's great, Shakib. Thank you. How about we go to Bennett next?
Sorry, battling the mute there. My name is Bennett Gankin. I work for the Veterans Benefits Administration, and I have about 10 years of federal experience. I actually served in the Marines prior to coming to the VA. So the VA has I have a personal connection to the mission and care a lot about trying to improve our service to veterans. Here in the Benefits Administration, we're the side of the VA that processes all of the benefits applications, so GI Bill, home loan, VRNE, counseling services. There's a wide variety of benefits that we offer veterans separate from the hospital administration side. A lot of people hear VA and they think of the hospital, but this is a separate agency that has a very important mission, and we pay out billions of dollars in benefits to ensure veterans have the services they need to be successful. And so it's a great mission. And I actually studied data science at Regis University and learned a lot of the academics of programming and AI, and got very interested in how we could bring this to bear to improve our benefits processing and how we do things as an agency. So, we've done a variety of enhancements trying to work through that predictive analytics. I've also heard the term used of prescriptive analytics, where we try to take it a step further and prescribe what the next action should be taken. And we're definitely focused on the operational side of trying to really apply the analytics. So, a lot of it is, how do we actually directly apply the analytics to classify things or clean up data or reduce human steps that have to be taken so that our humans can spend more time analyzing and doing more thoughtful work and less time cleaning up data entries or manually processing forms. So it's been very exciting. We have efforts in fraud, waste, and abuse similarly to try to prevent any potential issues there. And we have a few efforts along enhanced benefits processing. One of the biggest ones that I've been working on right now is actually a partnership we have a contract with IBM and Aptiv to use artificial intelligence and RPA and OCR in order to extract information from incoming mail and properly triage and route it downstream, aligning, essentially replicating what humans used to do and freeing them up to analyze claims and work them instead. So it's been a really exciting process over the past year, and we've made a lot of really impressive progress, in my opinion. Yeah. Thanks.
Excellent. Thank you. Alex?
Thank you. It's and thanks for having me here. It's nice to be here. So my name is Alex. I'm an economist turned maybe machine learning practitioner would be a good title for it. At the Bureau of Labor Statistics. You're probably familiar with some of the outputs of the Bureau of Labor Statistics. We do the unemployment numbers, the inflation numbers, but in fact, we collect information and produce statistics about many different things, including something that I spend a lot of time working on, which is workplace safety and injury statistics. And that's an area where predictive analytics has been playing an increasingly important role, especially in helping us process the text information that we receive. If you think about how it is that we go about producing all these statistics at BLS, well, one of the ways is that we go out and ask people for the information. And so we asked someone if they worked in a couple of weeks ago. We asked people if they were injured last year. And the responses we get come back in the form of language. And so we spend a lot of time analyzing and processing that language. And this is an area where increasingly predictive analytics is helping us perform, not only improve the quality of this task, but also automate, improve the efficiency of the task. And maybe the best example of this is for our survey of occupational injuries and illnesses, which each year collects hundreds of thousands of written descriptions of these injuries and illnesses. 6 years ago, we were doing all of this work by hand. This past year, we did more than 85% of the coding and classification of the data using deep neural networks. So predictive analytics is very quickly changing the way that we collect and process, especially language information at the Bureau of Labor Statistics. But it's also now changing the way that we do other things, things like record matching, so that we can pull data sources, combine data sources from many different locations. We're using it also to increasingly help us detect errors in the data that we're collecting. And we're using it to help us collect information, to extract information from news sources of information, things like news articles and other administrative records. So predictive analytics is a very important sort of technology now that is changing the way that we produce government statistics, and I'm very happy to be here to talk more about it.
Thanks so much, Alex. That was a great perspective. It sounds like, and I've noticed this in AI and machine learning abroad, that there are so many use cases that can be leveraged with these tools, with predictive analytic tools and machine learning. If I'm an organizational leader and I want to modernize my approach, my workflows, what do I do? What's my first step? Do I need predictive analytics in my organization? What are some of the things that I can look at in my organization to see that whether or not I need the tools and the capabilities that predictive analytics really helps? If you could, please explain what some of those things I should be looking for as an analyst, and maybe some challenges and pitfalls we can avoid as business leaders before we start investing in these kinds of tools. And I'll open it up to the group, whoever wants to jump in first.
Well, let me tackle that first, if you don't mind. I mean, like I explained, NTIS we have a unique framework, which is innovation framework, and it's going to resonate with a lot of people who are in the federal sector, because we operate outside the FAR, and we in partnership with the private sector and nonprofit organization. I think the first thing that what we do and what is unique about us, and that's our secret sauce, is to look at the problem rather than solution. It's not like a solution which is predictive analytics. Yeah, it can be very helpful in many areas, but it's not like, okay, we're looking for a problem to use it for. I think when we have a federal agency, when we get in touch with federal agency, we ask them about their problems, what their pain points are, and then try to identify what really will make them achieve their mission more effectively and more efficiently. And the secret sauce that we have at the NTIS is that we involve the private sector very early on. We call it the pre-solicitation phase. Actually, when we develop a problem statement with a very quick one with the federal agency about a specific pain point or specific objective that we want to achieve, and we define what are the business requirements and the success factors, we bring in the private sector for them to help us actually on the problem statement rather than the solution. And then once we have that problem statement with that input from our list of privated partners, then we produce what we call a project opportunity announcement, and then we ask for from our list to come up with proposals to achieve the prototype and proof of concept. So the main thing, my point here is that when a federal agency wants to use AI and others, first let's look at the problem. That's number one, identify the problem. And number two, try to see how we can actually address that problem the most efficient way. And typically, because AI is so powerful, it's going to involve some AI component and eventually maybe predictive analytics. Number three, that we always work with federal agencies, and that's Tony mentioned at the beginning, that spend a lot of time on, and then federal agencies have to spend a lot of time on this because we have a wide spectrum, and that's of cases in the federal sector. We have like some basic application of AI. We have some very advanced. We're working with Jake, for instance, in some very advanced AI technique. And a lot of people are in the middle and they don't know what to do. So our framework allows them to explore, to innovate. Innovate is about permission to take risk. So they don't have to go to the far where they have to know exactly what they're supposed to do. They say, okay, we have a pain point. I want to see if I can have this using maybe AI or predictive analytics. Let's explore that. And that's fine to adapt. We have a very agile framework that allowed them to actually and allowed us and the partners to change things, because that's how when you do innovation, you don't know what you're going to be exploring, but you know how to address a problem. That's what we try to do. So that's what we've been doing. For instance, with Jake and the Department of Energy, we have been working on issues that relate to national security, for instance. Looking at how to use predictive analytics and deep learning algorithms to sniff across a lot of data, like for instance logs. Like if we try to find if there are some malicious activities within the network. So we sniff that, and we use predictive analytics to try to predict unusual patterns that are known or unknown. That's the advantage of AI, is that you can also detect unknown patterns that you haven't thought about, and that help us surface those and bring them, like Bennett mentioned, to the specialists, human beings that are specialists in that area that can actually interpret that data and then take the right action and make the right recommendations. Thank you.
And if I could go ahead, Alex.
Oh, sorry. I'm sorry, Ben. So I just wanted to echo, one of the things that Shakib said is you start with the problem, not with the solution. And the truth is that predictive analytics is not the solution to every problem. So it's always a good idea to start with the problem. That said, predictive analytics is a very powerful solution to many very difficult problems. And we're increasingly finding areas where it is very useful. And I think we went through this process of, starting from ground zero where we didn't know much about it to actually using it now extensively. And we sort of acquired some, I think, interesting lessons along the way. I think one of the important lessons that we got early on was it's important to have someone inside who understands something about predictive analytics. It's very easy for sort of outsiders to make lots of promises about what predictive analytics is going to be, but it's very important that you be able to verify those claims and understand how it works, so that you can get a solution that ends up working for you. So I know in our case, when we were first starting, we tried a few different contractors and asked them to develop prototypes, and then we set up an evaluation that allowed us to compare the solutions that we got, and that was very important in allowing us to get a good solution that ended up working well for us. I think another important consideration when using predictive analytics is is how that predictive analytics works. Very often the tool behind predictive analytics is machine learning. Machine learning is a very powerful tool for many tasks, but it has some requirements, and you need to make sure that you meet those requirements. And one of those requirements is that you need training data. So ideally, this is data showing the inputs to the task and the outputs that you want to get for those inputs. If you have lots of that data, very often you can get excellent solutions with machine learning. If you don't have that data, however, you may need to rethink things. You may, there are some situations where you're lucky that, other people already have the data, and so they've built models you can use. But there are a lot of situations where you're going to have to get the data first. I think the next step, once you decide that you need predictive analytics, and once you have someone who understands how to do it, is to look at the data and see if you have the data that you need to do it, because that's another critical step in the process.
Thank you, Alex.
Yeah, Alex said everything I was going to say. Like, it really is starting with the problem and then mapping the data. And I would take it a step further. Like, once you recognize where the data, where the inputs are coming from, mapping the whole business process through. Because if there's intuitive leaps in the process, or if you discover someone's using outside references that aren't readily tied into the process, and so they're, we've seen in some of our processes where someone looks at something and they say, oh, that one's a grant or that one's a deny. And I say, why would you know that? And they go, well, it's according to this and that regulation or this reference, and it's not written down anywhere. It's not in the system. It's something that they know to look up and they've been trained on. And so drawing out that subject matter expertise and mapping your business process is critical, so that to Alex's point, you can have the inputs and the outputs line up, and you can actually, make something of predictive analytics. You can't use them if there's intuitive leaps somewhere in that process, and the inputs and outputs cannot, essentially there's something opaque in between them.
Excellent. That was very useful, Bennett. This is sort of a two-part question, and before we turn it over to the audience, but how much data do I need? If I want to run some predictive analytic processes, how do I know I have enough data? And can you give me an example, and I'm going to ask the panel this, of some big problem you were able to solve with predictive analytics, and what value it brought to the organization?
I can answer the data. Whatever you think you have, it might not be enough. There's, more data is almost always better. One of our key problems was classifying veterans' claimed disabilities that come in on their forms. So they say, my ear, I have ringing in my ears, or something like that. You need to know that that's hearing loss, classify it as such, so that you can send them to an audiologist for an appointment. You don't want to send them to the wrong doctor, because then they won't get the right exam. So driving the right classifications is a classic machine learning problem, where you have free text inputs and you need to classify those into specific categories. I was able to go back and pull over 7 million examples of where humans had classified things. And honestly, that was barely enough. Some of the edge cases, in my opinion, didn't have enough, and looking at the outputs of the algorithms, didn't have enough examples to always classify correctly. And that was after, of course, there was some cleansing and everything to make sure that we eliminated some bad data in there. But in general, whatever data you think you have, more is always better. I don't know,
Yeah.
Alex.
Yeah, no, that's a great question. How much data do I need? That's a question actually that my colleagues have been asking me, because we're in the process of transitioning one of our systems to a new data structure. And so the question is, how much data do we need? And my answer, at least so far, is I have no idea. What I've seen in my experience is the more data we have, typically the better performance we get. You can do simple sort of experiments where you test this. but there's always there's always stuff, there's always data that you need that you don't have, and it's important to to design your system around that. You know, one thing that's coming up this year is, of course, the COVID crisis. That's a new type of data that you're going to be seeing in those veterans benefits claims things. It's a new type of data that we're going to be seeing in our injury and illness statistics, and it's data that we don't have in our training data set because we never had we never had this particular virus in the data set. So it's important to have sort of backup systems in place so that when you don't have the data that you need, humans can take over. One of the things that we do with some of our injury and illness classification is that we don't fully automate the task. We turn it into sort of hybrid task. We use the machine learning to do the stuff that's routine, that the machine learning system has seen a million times before, that we have where we have the data. And then we kick it out to human staff for the stuff where we don't have the data. And I think it's important to have that in place because there's always going to be situations where you don't have the data you need.
Let me make a couple of quick points on this. So before we open up to question and answers, of course, I echoed what Alex and Bennett said about the importance of data. So, and because predictive analytics is fundamentally rooted in data. So, but one thing that is clear is that the most value comes from being able to collect, aggregate, and correlate information from different kind of systems. So this is the first thing that federal agencies have to do first, is to move from that silo system that exists now into more like shared platform, data platform, where actually each business unit can benefit from the data from others. So that's what we work with the federal agency first, to establish that. So that's number one. My second point is the fact that in order to the second point is when you have that data available and modernizing, then you're supposed to provide access to it, so establish some data governance, strong data governance policies and procedures to enable the sharing of the data. And that involves also the change of culture and try to instill the benefit that you can take from data. So that kind of that shift into more like the value that comes from data is increased in any organization.
All right. Yep. So we have a little bit of time for questions. We have some good questions here. So I'll sort of bring out the questions to the whole panel and Tony as well, chime on in. So actually some of these questions are directed at particular people, but you can chime in anyway. So this question was for Bennett. This is from Jose, and he asks, can you illustrate with some examples about prescriptive analytics in your organization? So we know it's topics on predictive, but this is questions about prescriptive, which I think you mentioned.
Mm-hmm.
Yeah.
Sure. Yeah. I mean, I might be wrong. I'm not going to pretend I'm the complete expert, but I see predictive analytics as where you're predicting where things are going, trends, future state, etc. Prescriptive takes that a step further to predicting what you should do next. So a great example would be, I could pull in a large amount of data and predict, future mail volumes or, specific trends in my overall data, which honestly this year with COVID, some of those models aren't as valid anymore, and we have to re-update and rebalance. But looking at prescriptive, something like predicting, a great example would be, sorry, I'm getting a little bit of an echo. Prescripting the correct next action to take in a system based on something we received. So right now, we're automating our incoming mail. And so, you receive a specific form, a veteran reporting that he has a new dependent and he wants to be paid additional funds because, he's adding the dependent to his award. We could prescribe the next correct action downstream and establish the correct claim in the system without a human intervening. So essentially just taking that action downstream and fully automating it. Instead of just kind of passively suggesting what the future looks like, actually prescribing actions that should be taken downstream. So that's one example from my agency, but honestly, prescriptive analytics, I feel like, is a whole different aspect of trying to apply it in. And I feel like that's some of what Alex is doing too, with directly prescribing the correct codes for things in his injury data. Like I don't know, it feels similar, Alex.
Yeah, and I don't know where one ends and the other begins, but right, part of what we're doing is sort of helping people decide what they should do next. What classification should they choose? What pair of records should they look at? And
to your point, some of that's confidence, right? Some of that's the confidence where if you're 100% confident this is the correct answer, maybe you want to consider that a prescriptive aspect and just automate it all the way. If you have a 50-50 guess, probably want a human to look at that.
Yeah, absolutely.
Yeah.
It's also like trying to set up an objective that you want to achieve and try to find what's the best model to achieve that. So what AI and predictive analytics can help you with is actually come up with the right decisions and recommendation to be able to achieve that objective. And that's what predictive algorithm can help you with. So give you the steps to achieve it, even if it's achievable or not, but at least give you do the analysis for you to see that how to achieve that and to give recommendation for that.
Okay, cool. Well, great. Yeah. And my understanding generally of prescriptive analytics is that it's sort of a lot of what if analysis. So even though you may be making a recommendation, the thing about prescriptive analytics is you could change some of your assumptions and then use the model to kind of figure out what would happen if you made those changes, even if so it's kind of like changing something to determine outputs. But there's lots of ways of because that's also called projective analytics. There's so many other terms that are kind of in this general realm. So another question, this one's for Alex. Actually, it's a follow-up to that, which is, Alex, is there any capability in your implementation to assure quality of the data set? So there's questions on quality. I'm sure that was a top indicator, top concern, right?
Yeah, that's a really big, that's a really important question that we deal with. And one of the big concerns when we first got started was, what is the quality of the data that we're training the model on? In our case, we knew that there were imperfections in the way the data had been coded manually, and so we wanted to make sure that the model that we trained on that would work. Well, what we found actually is that the model ended up outperforming the data it was trained on. So we could actually compare the performance of the model to the human people that had created the original training data, and we found the model was doing better. And you wonder, well, why is that? Well, what's happening, or what seems to be happening, is that the model is sort of averaging over these sort of random errors that people make. Maybe people, sort of fat finger something when they're putting the data in. Maybe they just sort of lose concentration for a second. And so when you have this sort of random distribution in the errors that in the data, you can address that. Now, the other question where data quality comes up is, how do you make sure that the model is assigning codes or classifications that are correct? And we've put into place a number of sort of processes to help us do that. One of the processes we have in place is that we have human staff manually reviewing the decisions made by the computer system and informing us when they find errors and making corrections. The other thing, we also do a couple other things. Another thing we do is we do a random holdback sample. It's a sample of stuff that doesn't get coded automatically. We do this so that we can see how humans would code it without the interference of a computer system. And surprisingly, it's quite different when they don't have that suggestion in front of them. There's actually quite a bit of a difference, and it allows us to see what kind of impact the automated coding is having on the process, and allows us, after some additional work, to actually monitor and continue to compare the manual and automated coding quality.
Okay. Anybody else want to talk just in general about ensuring quality in predictive systems? Because obviously, if you're going to use these models to make predictions, you're going to want to eliminate as many errors as we can.
Mm-hmm.
Yeah, go ahead, Bennett.
Yeah, I was going to say, one of the biggest challenges you'll see, in my opinion, on the business side is as you go towards the more advanced models and you start building deep learning and neural networks, you lose some of the explainability, where you can't, even though you might have like actually written the code, you can't explain exactly why, you know, this particular example is coded a particular way and a particular output occurred. And sometimes that leads to some suspiciousness of this quote unquote black box that just magically gets things right most of the time. And that's where I think it's important to do all the things Alex just said, have, you know, sampling, have humans still involved, so that you can establish that confidence in your model. Because if everything just goes in a black box and you're being told that the answers are correct, you know, you're pinning a lot on that. And if something goes wrong in your model over time, or if there's some sort of bias, you know, especially if we go back so many years and we're training off historical data, there might be a bias or a slant in the data over time that you don't want to carry forward. And in that space, you have to be really cautious to still have people involved to evaluate, and they might not be able to explain specific examples, but they can do samples like Alex pointed out. And I think that's a great approach, Alex.
Yeah, I also want to add to that, of course, data quality is essential in developing predictive analytics solutions. But the key point is for us to understand that the predictive analytics solution, it's a living software. It's not like you write it and then you're done. So it keeps learning. So the training data and the quality of that training data, as you develop that quality, they will give you better and better solutions. So it's an iterative process that goes on. So that's when we interact with federal agency and they said, where should we start? Right away, first start with shoring up your data platform, because data is key in all these type of solutions that we're going to be developing in the future. And data, Spigot is coming at you in real time. So you need to fix the data you had, but also the data that's coming up every day and adding up to that. So that's why it's very fundamental to modernize your data infrastructure, and then develop the data governance role and the policies, etc., to actually enrich the data as it's coming and enrich the one that has been there, because that's going to be the basis for effective and efficient solutions.
Great. Nobody else is chiming in. I got maybe time for one or two more questions, because I know we have we actually have something going on right now, by the way. I don't want to lose anybody here, because we have a lot of people have some questions. We have an Ask an Expert session going on right now. In session 53, I think it is, with Labelbox, and they're doing an expert session on data labeling. So I don't want to lose you guys, and the expert session is open. It's an Ask Me Anything, so you can go here and then go there afterwards. Just want to let you know that's happening right now. You're not going to lose. There's no presentation there. It's just sort of a open forum. So let me ask this next question here, and that has to somebody else. Eric is asking a question about having lots of data. So let's get into this. So you don't always hear it's like we heard the earlier question of what if I don't have enough, or well, how much do you need? So this question is, my organization has plenty of data, but in many different formats. And how would you go about preparing the data for an ML model or to use predictive analytics? So I guess we're talking about issues of data variety.
And I honestly say this is where we start having to talk about building a data lake, you know, establishing an organizational, like an enterprise strategy for how am I going to corral all this data into one place so that you can start doing those analytics. And honestly, with, you know, where cloud computing's gone and all of the different awesome new platforms that are out there, it's more of a matter of which one do you want, rather than, you know, I would highly recommend looking at what's off the shelf that's already solved some of these problems, and then figuring out how to customize it to meet your needs. You don't need to reinvent the wheel per se. there's a lot in the space already. And once you get it into a lake or some sort of place, you can start looking for common keys, joining and doing predictions and creating curated data hubs of data that you've deemed useful to the business per se. I think Tom was gonna.
If I could jump in on that as well. I mean, it's really the first major step in the data science pipeline is to make sure you normalize your data, you impute it, you make sure it's all standardized. I can give you plenty of examples of where that impacts every step of extracting analytics, but you do need to have that baseline set up. As an example, on our platform at Veritone, we use the VTN standard, and all the data that is coming in has to be processed in such a way we're doing apples to apples comparisons. So it's very important for an organization. It's important to set up those data pipelines. A lot of folks I talk to that want to do AI, incorporate AI into their workflows, really have a data pipeline problem, right? They have spreadsheets, they have data in .csv files, they're on servers, they're in databases. So I would talk to an organization that's familiar with doing ETL and setting up those pipelines in which you can streamline that workflow. So you're not having to deal with all that messy data up front. You can really kind of get to the analytics part and applying the applications you want.
Okay, great. I think we're kind of getting near the end here, only because we have another session going here. But these questions are really so good. So I think maybe we'll ask one more here. And for those of you that still have questions, we're going to leave contact information available here. Just go to the session page. We'll do it. And this question has to do. Did I already mark it completed? No, I think that was it. Well, this question has to do with where does traditional non-AI predictive analytics leave off and AI machine learning based predictive analytics start? So maybe we'll do sort of the follow up, which is sort of like where's the AI and predictive analytics and kind of where does that start?
That's a great question, and that's one that comes up quite a bit actually in BLS, because we have a lot of statisticians, who are trained in the classical statistical learning techniques, and so they look at some of this machine learning stuff and they say, hey, that's just statistics. Well, it's true that the two fields are very closely related, and there are some sort of cultural differences, I think, between the two fields, but in my mind, they're really just sort of extensions of each other. Traditional statistical learning is focused historically, I think, on a lot of sort of theory and proving that you can get certain results from certain inputs. The difference between machine learning and statistical learning is that they've taken a lot of those tools and they've extended them so that they work on messy things where you don't have any clear theory. Like, what theory describes what language means? We don't have great theories on how that works. And so it turns out, with a few little simple modifications, you can actually turn these statistical learning algorithms into machine learning algorithms that can handle these complex, noisy things that otherwise are very difficult to work with. So the short answer, at least in my mind, is there is not a clear separation, but rather they're very closely related.
Okay. Any other feedback? That was really great. Can't argue with statisticians on that, so won't even try. Well, you guys have been fantastic. I want to give a great round of applause here to our fabulous audience for being so generous. Everybody asking questions. You guys were fantastic. I know we couldn't get to necessarily all of them. I tried to focus the ones that were more focused on predictive analytics and data. Tony, you have a question about sort of the role of China. So maybe take a look at the question. You can come back to that one as well. But really, you guys did a fantastic job. So a big round of applause for all of you that are interested in the Ask an Expert session. It's going on right now. It is, I know it's also lunchtime here, but it is session 53. It's the very next session. If you go to the top of the screen where you see the title of the conference and you click on more, it'll actually let you jump there. So you can actually just go there and jump there. I don't want to lose you all now, but I think I want to thank again the panel, the moderator. You guys did a fantastic job. This is like the panel on predictive analytics. So hopefully everybody will tune in, and we'll catch you all the next session. Thank you, everybody.
Thanks,
Ron.